Okay, so our next talk is about function specialization from Tom Scogland and collaborators from Lawrence Livermore. Tom, your turn.
Thanks very much. So, as you can guess, I'm not Georgis. He did a lot of the work on this paper, but he was unable to join us today, so I'm filling in for him on presenting our work, doing a more automated version of function specialization, especially across translation units. So we've done a lot of work in OpenMP specifically around addressing different performance and correctness and so on issues that you might have in functions. It's really, really important to be able to select versions of functions or versions of directives or versions of different things depending on what you have for all kinds of fun reasons. I'm sure if you talk to some MKL developers, they'll tell you all about getting the right one for performance. If you talk to some certain runtime or compiler developers, they'll probably have some war stories about getting math libraries that don't have native assembly embedded in them. So there's a lot of material here, but something that we really wanted out of variants early on is to actually pass context along, right? And so we look at some of these things we have, right? Context consists of traits. It's what constructs are there? What device are you on? What device would you be offloading to? What's going on in the program around you? What's your architecture? All kinds of things, right? And so we provide meta directives for this, which is a way that you can say compile time or runtime. Based on the context, use this directive or this directive. Maybe you want to offload to a GPU, or if you're already there, maybe you want to not try to offload again and blow up, right? It's just for that. Second one, declare variant. We only have one syntax up here. There are actually two. It's compile time selection of a user-defined variant function. This version lets you say, I want you to actually call the more specialized one if you're in a parallel or if you're in a target. The other one, begin end, lets you do bigger spans of functions and provides some context propagation into those functions. But the other ones don't. You do a declare variant caller here, for example, between bar and foo. You have the caller aware that you have the parallel construct context. The callee, however, does not necessarily know that. There are rules in the specification that say it absolutely must match that context if it gets called, but the compiler doesn't necessarily know that's the case, and so it can't necessarily actually take advantage of it. So this is a little bit unfortunate. It means we can't actually optimize based on this stuff. It means we can't specialize quite the way we want to. So we're playing around with the idea of something that we were calling meta variant because why not? More low edit distance names. What could go wrong? But the entire idea is let the compiler generate context-aware function variants for the base function. And then we have a way to attach kind of semantic naming to these variants so that you can get a reliable ABI across translation units. So callers can specialize the call side of a meta variant based on the context they have. And the variants can consume and propagate that context. But you still have the option in the compiler that's compiling the callee to generate or not certain of those variants. If it chooses to specialize them, it can, but you still get linking. Right, so an example of what we were trying to do, the actual function on the left, meta variant match construct parallel. Inside of it, you have a meta directive when construct parallel, do task loop, otherwise parallel for. might lower to something like a variant with the parallel construct context and a variant without it. In principle, it could have actually lowered to one function with an if statement and some stuff in here, as long as both of the target symbols expected by the ABI are emitted. So you might need to emit some aliases, things like that. But another one, a little bit more interesting, perhaps. You have a caller with a meta variant, again, construct parallel. You call from inside of a parallel region with mast, you call from a sequential context, and that automatically does what declare variant does. It selects the appropriate variant for this context. But because of the semantics of the meta variant, we're guaranteed that all of those endpoints get created, whether they're actually specialized or not. Now, to evaluate it, we pulled together a few different use cases: avoiding nested parallelism, avoiding nested target regions. This one actually came up. I had somebody send me some code saying, is this valid? This doesn't look valid to me. With a declare target function with a target region in it that wasn't doing reverse offload. It's just, let's offload again. Or supporting concurrent host and device execution. This is all set up using a blocked SGEM kernel, a Python source-to-source lowering tool. We had some support in Clang built in to do some of the symbol generation stuff, but it's mostly a source-to-source translator on Lawson, which is a Livermore system that is nodes much like Sierra. So IBM Power 9, V100 GPUs with a version of Clang 13-ish, 10 runs, etc. So the first example was avoiding nested parallelism using meta variant specialization or runtime specialization. So the meta variant generates SGEM. If you're under parallel, use task loop. If you're not under parallel, it generates a parallel 4. There are reasons for the difference, but the runtime specialization essentially did the omp in parallel check in an if statement, picks exactly the same interior code. And the default version does not so well because, well, OpenMP runtimes don't tremendously like it when you overschedule them massively, unless they're designed for it. So performance not great for default, but runtime and meta variant are relatively similar, with meta variant eking it out about 5% better than the runtime version, just because we're not doing a dynamic check. Tyler can tell we have a static call. In principle, with LTO, we would actually get better performance with this. A second use case, we're trying to avoid unspecified behavior from nesting target regions, or rather, we're trying to avoid compiler errors and provide a consistent interface simultaneously, which is occasionally harder than one would hope. The caller is set up, it's just target teams, some maps, SGEM. Whole point is you want to have one SGEM that somebody can use from target or from the host, and they don't have to care. So with the specialization, if it's inside of a target, it uses distribute. So this is if it assumes target teams effectively. Otherwise, it will launch it for you onto the device. Target teams distribute. Between the explicit and the meta variant version, the explicit is very slightly faster than the meta variant version. It's about 10 to 18%, because it loses some compiler optimizations compared to the combined construct. We have the target teams split across caller and callee. And it can't always analyze it through because they're separate compilation units and we didn't have LTO enabled in this. Combining it with the previous talk, we probably would get much of that back. And it's simpler code. You don't have to have two separate variants of SGEM or some interesting meta directives. So this one, we're looking at dividing work between CPU and GPU. This is something that we get asked, do people really do this? We have a couple of actual codes that really do this. Often because what they're doing works on a GPU, but works better on a CPU. So not using the CPUs loses for them. Caller looks relatively normal. It's a parallel 4. It's got a target teams map. It's just deciding, do we have enough work in this batch to bother paying to execute on the GPU? Meta variant does some selection. It says, okay, if we're in parallel or target, we'll select different variants. And we'll either do parallel 4 or we'll do distribute parallel 4. Now, doing just the CPU for this particular application is not a fantastic plan because this is SGEMs. GPU gets better. Having both CPU and GPU is another 5 to 10%, give or take. And again, it makes the interface more flexible so that the user has to care less what they specifically call. They get something sensible based on where they are. So running a little bit fast, but the meta variant directive, it helps us propagate context from callers to callees, especially across translation units. Within a translation unit, we have all kinds of great analysis in various different compilers, but we have a tendency to lose this unless we're doing LTO or whole program optimization. This is a way that you can explicitly cover it without having to specialize every single variant manually, which sometimes that's worth it. You know, if you're writing MKL and you want the last 2%, fantastic. But for some of us library authors, it really helps to be able to do these more generic interfaces, get the compiler to help some, but without overloading it with analysis. And in the end, it helps avoid performance and correctness defects and lets us get some more interesting kind of innovative uses of specialization. And with that, I'm finishing up a little bit early.
Thank you, Tom, for the talk. Any questions? I see one.
Thanks for the talk. So the idea is you annotate both TUs with the meta variant, right?
Essentially, it would normally be in a header file on a declaration kind of thing.
But both sides have to see it, otherwise you don't get the entry points. And you
That's
really
right.
want the entry points.
Yes.
Right?
That really is the significant kind of notable difference. It's actually a lot like declare SIMD if you want to think about it that way. In that
Right.
the main thing you get out of it is a way to be sure what entry points will exist. Except that we didn't want to have to force the compiler on the callee side to actually generate specialized code for all variants necessarily. Because it could be code bloat, other things. There are good reasons to want to make it dynamic in some cases. So collapsing them out, as long as you actually provide all those symbols, is.
Well, you basically just said declare SIMD. If I provide the definition for declare SIMD, I only generate code on demand, like SIMD code, right?
If you have the definition visible from the caller side, in principle, yes. But there's actually a sysv extended standard for generation of SIMD function names, like mangled names,
Right.
to work across translation units. That's the one I'm comparing to, really.
That brings me to the third and last question for this. What do we do with mangling?
Right. And that's a good question. It would be good to standardize on something for that specifically, but it would have to be context sensitive. Probably highly related to an open ticket by some, very forward-thinking person who was working on begin and declare variant at one point.
Someone was supposed to do the mangling thing and he dropped the ball on it. I don't know. I would kick those people out.
Thank you. Any more questions?
Thanks, Tom. You had an example earlier where I believe that it was using the meta variant with checking the target construct inside on a meta directive. So could you go back to the previous example where I think you had something? Yeah, this one, which is a pretty simple one. So in this case, it seems to me that meta variant wouldn't necessarily even be necessary as long as dgem is marked as declare target, which it might be done implicitly, because I think we say that for declare target, you get the target context for declare target device routines.
Right. So in this case, I believe that is... We do say that we weakened it at some point such that if we have another function in between,
okay,
then it doesn't necessarily carry through.
Okay.
But you're right. There are some cases like that where we can get some of this. Am I currently running on target? Right. Yeah, that whether it's device or not is a little bit special because we carry some information there already. But when it's, especially if you're already, I didn't have an example for it in the slides. I probably should have. But another place where this is helpful is if you're already in a target, and you don't necessarily know if you're at the teams level or if you're at the parallel level, is one that's much harder to handle. Because handling it dynamically, it destroys your performance because the checks are too expensive. And handling it statically doesn't propagate. So that might have been a better example for this, but it's a little hard to fit it on the slide.
Thank you.
More questions? Maybe also from the people joined by Zoom? I do have a question there. So the meta variant reminds me awful lot like on template instantiations. So you have a template and you have the if const x bar, which corresponds to the meta directive, and then you instantiate the template specific and chooses the correct variant there. You have explicit template instantiation, so you can choose which one you want to emit to an instantiation unit. Did you take some inspiration maybe from that one? Maybe also even in the name instead of meta variant, maybe instantiate variant something?
Yeah, it certainly could be. I mean, that certainly is part of the inspiration, both in what we wanted to do and what we wanted to avoid. Because template instantiation does a lot of this same stuff. It would get us to the same place. But template instantiation also always must instantiate a full copy for each instantiation, except in certain very specific cases where they emit to the same code. So we wanted to get that kind of behavior where you could rely on there being something on the other end. But if it's more efficient for some reason to collapse some of them to the same implementation, we wanted to leave that available. Meta variant, honestly, is kind of just the name we picked to make it sound like that class of stuff until we could come up with something better. It certainly could be instantiate or even just generate variants or something.
mean, it's not necessarily exclusive. If you have like a JavaScript engine or something, they have a generic version which does like dynamic dispatch for types, and then you have another specialized version depending on what it determines, one for integer. So you can have like a fallback version if you don't have a specialized function, uses generate a one which I don't know does something maybe at one time. I don't know.
Just to clarify, so the idea behind this one is that a valid implementation on the callee side would just be generate a couple of aliases for global symbols, call it a day, and go home.
It would be valid, yes.
Good.
I mean, ideally, you want to do a little bit more with that, but the point was to make something that would allow for specialization, but keep things kind of compatible between translation units, even if you're not doing that.
Yeah. You get full support of that really fast.
Right. And that it also means that caller side support is essentially identical to declare variant lookups. Right. I mean, it is not entirely identical, but it is close enough because you can just say the most specific context is the one I want to call it. Yeah, that was essentially the goal, is to make this is a way to make it easier to generate a set of declared variants.
All
right.
One more question.
You have to make them go, wait, no.
Yeah. And that part of the original thought was, if you have a list of contexts you know you might care about, we could say that and not necessarily have meta directive on the instance and let things be auto-generated, but that's a little bit harder to reason through exactly what the semantics are supposed to be. So we started here.
So, excuse me. I'm a bit confused by the usage of the combined construct here, because on the left you're using OMP target themes.
Yep.
On the right, the when construct applies only to target. So I wonder if that was OMP target only on the left, it would apply the distribute only, not the themes.
Yeah, that's right. So this one, really, it should be looking for both target and teams constructs, most likely. Yeah, I think
we only have a few limited ones, and as we keep developing this, we might want to think about if we want to allow other constructs to be included.
Right. There's definitely a trade-off there, because tracking some of them could be expensive, there could be problems, but at the same time, if we have the explicit context available, especially for things like this, and it could help make more ergonomic APIs without having to explicitly build them out.
Okay, let's finish up. Let's thank the speaker again.